What if I told you that an 18-year-old kid from Tennessee invented something in his damp, dimly lit garage that made professional racers question absolutely everything they knew about suspension technology? This teenager, armed with nothing but some cheap steel tubing, a borrowed welder, and a fundamental understanding of basic physics, created a device so violently effective that cars equipped with his invention could launch off the starting line with the exact same ferocity as professional, purpose-built race cars costing hundreds of thousands of dollars. We are talking about achieving 1.32 second 60-foot times. That is the kind of explosive, brutal launch that aggressively snaps your head back against the seat, compresses your spine, and leaves your internal organs playing a desperate game of catch-up. And here is the absolute kicker, the part that drove the professionals absolutely insane. His entire setup cost a grand total of $55. This is legacy motoring. And I spend way too much time thinking about the forgotten, brilliant innovations in automotive history that completely disrupted the racing establishment. If you're someone who loves diving deep into the grassroots engineering that built car culture and leveled the playing field for the everyday gearhead, make sure to hit the subscribe button and give this video a thumbs up if this helps you out. Picture this scene in your mind. It is 1975, and you're standing at a gritty local drag strip somewhere deep in the heart of Tennessee. The heavy summer air is thick with the stinging scent of vaporized tire smoke and the sweet burning exhaust of high-octane racing fuel. In the left lane, there is a guy sitting in a full-blown, commercially sponsored race car. It has a custom tubular chassis, a meticulously engineered 4-link rear suspension, and all the expensive bells and whistles you could ever imagine. Look, he's probably got 20 grand invested in that rear suspension alone, which in 1975 was enough money to buy a nice house in the suburbs. In the right lane, there's a kid sitting in a beat-up, daily-driven Chevelle. It still has the heavy, clunky factory leaf springs hanging under the back end, looking exactly like they did when the car rolled off the assembly line. But if you look closely, something is different. There are these two parallel bars running from the rear axle housing forward toward the chassis. They look simple, clean, and almost dangerously primitive. The Christmas tree drops its lights, the green flashes, both cars launch, and something mathematically impossible happens. The kid's beat-up Chevelle instantly plants its rear tires into the sticky asphalt and rockets forward with the exact same terrifying ferocity as the purpose-built $20,000 race car. The rich guy with the highly expensive 4-link setup simply cannot believe what he just witnessed through his helmet visor. He just got his doors completely blown off by a teenager with some welded steel water pipes. This is the untold, legendary story of how ladder bars revolutionized grassroots drag racing and quickly became the single greatest suspension equalizer in the entire history of the sport. It is a fascinating tale of pure innovation, born out of sheer financial necessity, where one teenager's intuitive understanding of physics and geometric leverage completely outsmarted millions of dollars in professional corporate racing development. And it all started because one stubborn kid flat out refused to accept the established narrative that you needed immensely deep pockets to go incredibly fast. To fully understand why this $55 invention was so unbelievably revolutionary, we really need to travel back to the early 1970s drag racing scene and look at the actual landscape. Back then, if you had a standard car with traditional leaf springs and you wanted to race it seriously on the weekends, you basically have 3 options available to you. And frankly, they all sucked in their own very special, very frustrating ways. Option 1 was the slapper bar. These were incredibly crude, heavy metal devices that awkwardly bolted to the front spring eye and extended backward under the axle housing. When you launched the car, the axle would forcefully rotate upward. The slapper bar would then swing up and hit a dense rubber snubber against the frame, and theoretically, this violent impact would force the tires down into the track. In reality, they worked about as consistently as a long-term weather forecast. Sometimes they would hook up beautifully, and sometimes they would completely unload the tires, and you literally never knew which result you were going to get until you were already swerving halfway down the track. Now, you might be thinking, what about bolted traction bars? Well, that was option 2. These rigid bars firmly clamped directly to the leaf spring itself and were supposedly designed to prevent the spring from wrapping up under heavy acceleration. Here's the massive problem with that idea. They effectively turned your flexible dynamic leaf spring into a completely solid, unmoving iron bar, which essentially meant your suspension was no longer actually suspending anything at all. Every single bump, every microscopic track imperfection, and every tiny variation in the racing surface would violently unsettle the entire chassis of the car. Plus, the extreme rigid stress would eventually crack your expensive factory leaf springs right in half, leaving you completely stranded on the side of the road with a broken car, a bruised ego, and an entirely empty wallet. Option 3 was what everyone simply called the nuclear option. You had to physically tear out the entire factory rear suspension system and install a professional custom fabricated 4-link setup. This drastic path meant taking a heavy cutting torch and permanently slicing off the factory spring purchase, welding in entirely new heavy-duty metal brackets, fabricating or purchasing a complex 4-link geometry kit, installing costly adjustable coil-over shocks, and basically re-engineering the entire structural rear half of your automobile. You're easily looking at thousands of dollars in specialized components alone, and that is not even counting the massive labor costs if you could not precisely weld it all yourself. And once you finally finished doing all this expensive cutting and welding, your reliable street car was not really a street car anymore. Those rigid 4-link setups were absolutely brilliant for a perfectly prepped racing surface, but they were absolute, unforgiving murder on a public street. Driving over a simple highway expansion joint felt exactly like someone was standing directly behind your seat and taking a heavy sledgehammer directly to your lower spine. The established, unquestioned racing wisdom of the era explicitly stated that these were your only 3 choices. You either dealt with maddeningly inconsistent launches, you physically destroyed your daily driver, or you opened up your wallet, took out a second mortgage, and converted your weekend cruiser into a dedicated, uncompromising race machine. There was absolutely no middle ground whatsoever. The wealthy professional racers, the big corporate suspension companies, and the mainstream automotive magazines had everyone thoroughly convinced that achieving good, consistent traction definitively required highly complex geometry, incredibly expensive machine components, and essentially ruining your car's streetability. Here's what most people don't realize about leaf springs. The underlying problem with them was not actually the springs themselves. It was purely about how those long strips of metal physically reacted to the massive application of rotational torque. When you aggressively hammer the throttle pedal to the floor, the internal pinion gear inside the differential desperately tries to climb up the ring gear. This massive, sudden rotational force desperately wants to wrap the flat leaf springs into a tight S shape. Imagine holding a thick piece of plastic and trying to twist the ends in opposite directions. The more raw engine power you make, the infinitely worse this twisting effect gets. It is exactly like trying to push a heavy, limp rope across a long table. The metal springs violently wind up tight, they physically store a massive amount of kinetic energy, and then they suddenly release all that stored energy violently and completely unpredictably. Sometimes they would politely release that energy into smooth forward motion. Sometimes they would release it into violent, car-shaking wheel hop that would shatter your universal joints into a million pieces. Sometimes they would just instantly break traction and spin the tires into a cloud of useless white smoke. It was a complete and utter crapshoot every single time you approached the starting line, completely ruining the exact consistency that bracket racing absolutely demanded. But our young, brilliant Tennessee inventor realized something profound while staring at his car in the garage. He hypothesized that if he could somehow strictly control the violent rotation of the heavy axle housing, if you could permanently prevent that destructive spring wrap-up while simultaneously still allowing the entire suspension to smoothly move up and down vertically, you would instantly solve the entire traction problem without ruining the ride quality. And this is where it gets really interesting. Instead of stubbornly trying to make the leaf springs completely rigid like the bolt-on traction bars did, or arrogantly replacing the entire system entirely like the expensive 4-link setups did, this teenager brilliantly decided to simply work with the existing engineering. He let the factory leaf springs do what they actually do best: gently support the heavy weight of the car and provide a relatively smooth, comfortable ride down the highway. But he ingeniously added a completely secondary, beautifully simple mechanical system that only engaged to strictly control the rotational twisting forces. The solution was 2 parallel bars running from the axle housing forward to the frame, completely changing the game forever. But building it was only half the battle. The real genius was hidden entirely in the geometry. Here's the thing about making a car hook up on a drag strip. It is not just about keeping the tires completely flat against the pavement. It is heavily about how you physically transfer the static weight of the heavy engine block from the front tires directly over to the rear tires during that violent split second of initial acceleration. To understand exactly how these two simple metal bars accomplish this seemingly impossible mechanical feat, we have to talk about something called the instant center. Now, you might be thinking, what on earth is an instant center, and why should I care if I just want to go fast? Look, the instant center is essentially the invisible theoretical point in empty space around which your entire suspension system physically rotates when you view the car directly from the side profile. Think of it exactly like the mechanical fulcrum of a childhood seesaw. If you get the exact placement of that invisible fulcrum perfectly right, the heady car launches perfectly level and hits the tires incredibly hard. But if you get that geometric calculation even slightly wrong, you're either doing massive, uncontrollable wheelies that smash your oil pan into pieces, or you simply cannot get the rear slick tires to bite into the sticky track surface at all. Professional, expensive four-link suspensions could theoretically adjust this critical instant center to absolute perfection. Sure, they could do it, but it explicitly required highly complex mathematical calculations, sophisticated measurement tools, and multiple physical adjustment points that had to be moved in perfect synchronization. This is where it gets really interesting. This anonymous teenager's cheap ladder bars miraculously achieved nearly the exact same flawless weight transfer effect with completely fixed, unmoving mounting points and incredibly simple, straightforward geometry. The long steel bars were typically mounted to the car frame with the front pivot point positioned slightly higher than the rear attachment point. This created an instant geometric center that was positioned forward in the chassis and located just slightly above the vehicle's natural center of gravity. During a hard launch, this specific structural geometry forcefully caused the entire rear body of the car to purposefully squat downward slightly, aggressively transferring massive amounts of weight directly to the rear tires while safely keeping the lighter front end firmly planted on the racing surface. The actual physical construction of these game-changing devices could not have been any simpler if you actively tried. We're talking about exactly 2 straight pieces of standard steel tubing, probably 2 inches in total diameter, maybe 2.5 inches if the car was making serious horsepower. Add in exactly 4 heavy-duty rod ends, which are basically just heavy-duty industrial-grade metal ball joints that allowed the thick steel bars to pivot smoothly without binding up. Then, you just needed a few simple metal brackets to securely mount the entire contraption directly to the thick metal axle housing. These rear brackets were usually just thick steel plates quickly welded into a basic U-shape. The forward frame mounting points could literally be as simple as flat metal tabs permanently welded right to the chassis frame rails. That is completely it. The total material cost in 1975 was right around $55 if you actually splurged and bought high-quality name-brand rod ends. If you went cheap and bought surplus parts, you might get it done for $35. Any halfway competent weekend mechanic with a basic arc welder could easily build and install a custom set on a Saturday afternoon. There were absolutely no specialized professional tools required beyond that welder, a basic power drill, and some standard hand tools you already had sitting in your toolbox. There was absolutely no expensive engineering degree needed to fundamentally understand exactly how they mechanically worked. There were absolutely no complex, mind-bending mathematical calculations required to figure out the exact chassis mounting points. There were already some very basic, common-sense guidelines rapidly established through trial and error at the local tracks. You simply mount the front of the steel bars exactly 2 inches higher than the rear axle mount. You keep them as absolutely long as practically possible for your specific vehicle wheelbase. You make completely sure they physically clear the floorboards and exhaust pipes through the entire full range of vertical suspension travel, and you are completely done. The very first time our brilliant Tennessee teenager actually tested his crude homemade creation at the local drag strip, even he was profoundly surprised by the violently explosive results. We are talking about immediate, neck-snapping, violent forward acceleration. The wide rear tires aggressively bit into the sticky asphalt exactly like they were permanently glued down to the earth. The heavy car launched perfectly straight and incredibly true. There was absolutely no mechanical drama, absolutely no violent wheel hop, and purely forward thrust. But here's what most people do not realize about that legendary first test. It did this flawlessly and consistently. Run after run, pass after brutal pass, the heavy street car would aggressively leave the starting line exactly the same predictable way every single time. The 60-foot timing slips told the entire undeniable story to anyone who was willing to pay attention. For those who are not intimately familiar with the intricate mechanics of drag racing, the 60-foot time precisely measures exactly how long it takes a vehicle to physically cover the first 60 feet of track from a completely dead stop. It is universally considered the single most critical performance measurement in all of drag racing because it mathematically proves exactly how well a heavy car actually launches. A genuinely good, fast street car with decent modern traction modifications might consistently run a 2.0 second 60-foot flat time. What kind of four-link is that? That was the exact question echoing through the pits every single time this kid made a pass. You have to picture the utter confusion spreading through the local Tennessee racing community like an absolute wildfire. Grown men, seasoned veterans who had spent literally decades fine-tuning their heavily modified, incredibly expensive race cars would angrily storm over to the teenager's pit area. They would crouch down, peer under the dirty rear bumper of his daily driven Chevelle, and just stare in completely stunned silence. They expected to see a mechanical masterpiece of aerospace-grade aluminum and complex multi-point adjustable brackets. Instead, they saw two pieces of cheap steel tubing welded to the axle. When they demanded to know what kind of secret, underground four-link system he was running, the kid would just shrug and say he wasn't running links at all. He was just using ladder bars on his factory leaf springs. Look, the initial reaction was always pure, unfiltered denial. It was completely impossible, they said. But the official track time slips absolutely did not lie. Those heavy, steel-bodied ladder bar cars were consistently cutting 60-foot times in the 1.3-second range. Here's what most people do not realize about those early reactions. It was not just that the ladder bars were miraculously matching the expensive four-link setups. In many cases, on those unprepared, slippery local tracks, they were actually beating them. Now you might be thinking, how on earth could a completely primitive, non-adjustable piece of water pipe outperform a highly engineered, professional suspension system? Is physics just broken? Here's the thing. A properly, meticulously tuned four-link suspension system could technically still edge out a basic ladder bar setup. But that word, properly, is doing a massive amount of heavy lifting. Four links possess multiple, highly sensitive adjustment points, incredibly complex converging geometry lines, and explicitly required significant professional-level expertise to tune correctly for different track conditions. If you got any single minor adjustment, even slightly wrong, your hugely expensive, custom-fabricated suspension was actually significantly slower than the stock factory setup. Think of it like this. Using a complex four-link suspension was exactly like handing a highly complicated, professional-grade DSLR camera with 50 different manual settings to a complete amateur. Sure, in the hands of a master photographer, it takes a breathtaking, award-winning photograph. But in the hands of an average guy, the picture is completely blurry, completely out of focus, and completely useless. The ladder bar, on the other hand, was the ultimate mechanical point-and-shoot camera. It had basically one single geometric job, and it executed that specific job absolutely perfectly every single time you hit the throttle. Professional racers and arrogant chassis builders initially dismissed this exploding ladder bar phenomenon completely out of hand. It went directly against absolutely everything they passionately preached about advanced suspension design. They had spent years developing complex anti-squat percentages, mathematically calculating dynamic instant centers, and fine-tuning microscopic adjustment points. The answer to why the teenager's invention worked so flawlessly lay entirely in the beautiful, undeniable simplicity of the raw design. Four-link suspensions were theoretically superior because they could be tuned for literally any condition, any dramatic weight transfer characteristic, or any specific driving style. But that infinite tunability was simultaneously their greatest, most fatal weakness. Unless you knew exactly what you were doing, you were just blindly guessing. Ladder bars entirely removed the dangerous guesswork from the equation. They provided one rigid, completely unchangeable geometry that mathematically worked incredibly well for about 90% of all drag racing applications. They simply could not be adjusted incorrectly because they physically could not be adjusted at all. You bolted them securely into the car, and they just fundamentally worked, period. There was absolutely no tuning, absolutely no complex math calculations on the tailgate of a truck, and absolutely no frustrating trial and error. Just brutal, consistent, entirely predictable forward performance. This is where it gets really interesting regarding the underlying physics. When you violently accelerate a heavy automobile, equipped with traditional leaf springs, several massive physical forces instantly come into play simultaneously. First, there is the incredibly obvious rotational torque, desperately trying to flip the entire heavy axle housing completely upside down. But there is also the massive sudden weight transfer dynamically trying to compress the rear springs downward. The metal springs themselves desperately trying to maintain their original curved shape, and the complex geometric relationship between all the various chassis mounting points affecting exactly how these immense forces interact. Traditional leaf springs suffer from what structural engineers call a violently floating instant center. As the metal springs dramatically compress and rapidly extend under heavy load, the theoretical point in space around which they technically rotate constantly and unpredictably changes position. This chaotic movement makes perfectly predicting their dynamic behavior nearly mathematically impossible under hard, violent acceleration. The metal springs might compress entirely uniformly, or the front segment might violently wrap up into a knot while the rear segment stays completely flat. Each totally different scenario produces wildly different, incredibly frustrating traction characteristics. Ladder bars permanently fix that floating instant center into a single concrete location. Those two thick parallel steel bars created a strictly defined immovable point in geometric space around which the heavy rear axle physically had to rotate. The factory leaf springs were still sitting right there, still passively supporting the heavy physical weight of the car body, still providing some necessary compliance for decent ride quality, but they were no longer structurally responsible for painfully controlling the massive rotational forces of the engine. They could finally just do their one single job of holding the car up, while the heavy-duty ladder bars strictly handled the brutal acceleration forces. This beautiful division of labor instantly solved a massive engineering headache. The impact on bracket racing was profound, and honestly, it completely altered the fundamental DNA of the grassroots sport overnight. Here's the thing about bracket racing that most casual automotive fans completely and utterly misunderstand. It is absolutely not about having the fastest, most ridiculously expensive car on the property. It is entirely 100% about mathematical, repeatable consistency. You are strictly trying to run the exact same elapsed time, down to the absolute thousandth of a second, pass after agonizing pass. Inconsistent, entirely unpredictable launches were the absolute worst enemy of any serious bracket racer everywhere right today. And this anonymous teenager's incredibly cheap invention delivered mechanical consistency in absolute spades. Cars that previously struggled mightily to run the exact same time twice in a single row, violently spinning their rear tires one run and violently hopping the next, were suddenly clicking off runs within microscopic fractions of a single second of each other. The playing field had been violently, aggressively leveled by two simple pieces of cheap steel pipe. It was no longer a frustrating battle of who had the most disposable income to dump into custom suspension fabrication. It instantly became a pure, unadulterated driving battle. Now, you might be thinking, surely the illegal street racing guys completely ignored this track-only modification, right? Look, the street racers actually adopted these ladder bars even faster than the dedicated bracket racers did, and the underlying reason is brilliantly simple. Here was a highly effective, incredibly cheap modification that you could literally execute in your own damn driveway on a Saturday morning, and it would completely, fundamentally transform your heavy street car's launching ability without entirely ruining its polite street manners. Unlike those massively expensive, highly complex four-link systems, which typically required aggressively cutting the steel floor pans entirely, executing serious, permanent structural modifications was scary. Ladder bars could often be installed with relatively minimal permanent changes to the factory steel chassis. Some of the most ingenious, early homemade designs even allowed you to entirely retain the stock factory spring shackles and rubber bushings, directly meaning you could completely return the vehicle back to a bone stock configuration if you ever needed to sell it to an unsuspecting buyer. The highly competitive, dangerous underground street racing scene in the late 1970s was completely, irreversibly transformed by the sudden introduction of these cheap, incredibly effective ladder bars across the country. Heavy, sluggish cars that were previously considered complete and utter also transway are talking about massive, heavy steel-bodied sedans, clunky leaf spring Novas, and honestly, even some standard pickup trucks were suddenly incredibly, violently competitive off the starting line. A properly, simply set up ladder bar car could absolutely hang right with expensive factory four-link cars, like the prestigious Chevrolet Corvette in pure, straight-line, brutal forward acceleration. The legendary high-stakes stoplight-to-stoplight street battles that purely defined the automotive street racing culture of that specific era were suddenly no longer rigidly predetermined simply by a vehicle's factory rear suspension structural design or limitations. This is where it gets really interesting for the massive automotive aftermarket industry. The smart performance shops finally woke up and started actively offering commercial ladder bar kits to the general public. By 1976, major aftermarket companies, specifically like Lakewood, Competition Engineering, and eventually others, clearly saw the massive, exploding grassroots demand and started rapidly producing simple, bolt-in commercial kits for the most popular vehicle applications. According to industry sales data from that era, suspension component sales spiked dramatically, with bolt-on traction devices seeing a nearly 400% increase in retail volume in just 2 very short years. These manufactured production versions naturally refined the crude, basic garage concept, actively adding improved features like slightly adjustable front mounting points, durable polyurethane mounting bushings instead of harsh, noisy metal rod ends for daily street use, and highly detailed, step-by-step printed installation instructions. But the fundamental, underlying geometry and the pure mechanical design remained absolutely 100% unchanged from that original, brilliant Tennessee garage creation. The incredibly stubborn professional racing establishment eventually had to begrudgingly acknowledge what the grassroots bracket racers and the illegal street racers already firmly knew as absolute, undeniable gospel truth regarding rear suspension vehicle dynamics. Ladder bars undeniably worked. By the late 1970s, even some highly sponsored professional stock and superstock class racers were actively using ladder bar setups on their heavily restricted leaf spring race cars. The massive NHRA and IHRA official rulebooks were specifically carefully updated to explicitly allow ladder bars in restrictive classes where they formerly maintained the strict stock-type suspension requirement. Here's what most people don't realize about this specific era of drag racing. The most impressive, undeniable validation came directly from the strictly recorded elapsed times on the official electronic track clocks at the strip. Heavy steel door leaf spring cars equipped with these simple ladder bars were violently running incredibly deep into the 10s, the 9s, and astonishingly, even the high 8s in some specific, highly modified cases. These were definitely not just slow, consistent bracket cars anymore. They were legitimate, terrifyingly fast race cars running legitimate professional race car times. The old, tired, wealthy man's excuse that you absolutely needed a $10,000 four-link suspension system to go incredibly fast was officially, permanently dead and buried forever. You simply needed pure, unadulterated traction to go fast, and ladder bars violently provided that exact traction instantly. Think of it exactly like the invention of the cheap, reliable ballpoint pen. Before it existed, if you wanted to write smoothly and consistently, you had to buy a massively expensive, leak-prone fountain pen that required constant maintenance and a gentle touch. Then, suddenly, a cheap, perfectly functional alternative hits the open market, and suddenly, absolutely everyone can write perfectly without spending a fortune. That is exactly what ladder bars did for the beautiful sport of drag racing. They took a highly specialized, incredibly expensive mechanical function and flawlessly packaged it into a cheap, universally accessible, brilliant grassroots format. The technical evolution didn't stop there, but the underlying philosophy changed everything. Here is the thing about brilliant mechanical engineering that most people do not realize. When a fundamental design is absolutely mathematically perfect, the subsequent evolution is purely about refining the materials, not necessarily changing the geometry. Call track bars, which were aggressively introduced to the performance market in the early 1980s, precisely represented a brilliant modern evolution of that basic, crude garage ladder bar concept. They elegantly split the mechanical difference completely between a pure solid ladder bar and an old-school traction bar by brilliantly utilizing a single thick lower bar integrated with a highly specialized dynamic spring-loaded mechanism that forcefully preloaded the entire rear suspension system. While they were technically legally different from the true original parallel ladder bars, they flawlessly operated on the exact same underlying, undeniable physical principle, strictly control the violent axle rotation while seamlessly allowing smooth vertical movement. The massive, undeniable influence of these simple ladder bars rapidly extended far beyond just the sticky asphalt of amateur and professional drag racing. This is where it gets really interesting. Dirt circle track racers who constantly battled incredibly loose, unpredictable traction conditions quickly discovered that these cheap ladder bars could miraculously help accurately control massive axle wrap under heavy, brutal acceleration out of tight, slippery corners. Hardcore professional off-road racers rapidly found out that parallel ladder bars effectively prevented violent, parts-breaking axle wrap when slowly crawling up incredibly steep, rocky obstacles in the desert. Even some heavy-duty commercial towing applications significantly benefited from the ladder bar's innate, structural ability to rigidly control erratic axle movement under massively heavy, shifting trailer loads. By the mid-1980s, these cheap ladder bars had become so universally ubiquitous across the country that they were widely considered absolute standard equipment for literally any serious competitive leaf spring drag car. The common pit phrase, ladder bar car, actually became an incredibly respected, universally understood shorthand for a perfectly sorted, deadly consistent launching street and strip machine. It was a literal badge of honor, proudly indicating that the specific owner was incredibly serious about maximizing straight-line performance, but also incredibly smart about actually spending their hard-earned money. Now, you might be thinking, surely, modern computer-aided design eventually rendered this teenager's crude, $55 invention completely obsolete, right? Look, the financial and technological impact of the basic ladder bar invention is honestly hard to overstate. Consider that a typical professionally installed 4-link conversion in 1975 cost right around $3,000, which absolutely did not even include the massive custom labor hours. If just 1,000 average weekend racers intelligently chose to install cheap ladder bars instead of expensive 4-links, that is nearly $3 million that permanently stayed squarely in the working-class racers' pockets. That is pure, unadulterated money that could easily go toward building bigger engines, buying stickier tires, or simply allowing them to actually afford racing more often during the long summer. Modern, highly sophisticated computer suspension modeling has beautifully, undeniably validated exactly what that young, anonymous Tennessee inventor intuitively figured out through pure trial and error experimentation. The specific structural geometry he literally stumbled upon. Thick steel bars securely mounted at a very slight upward angle, carefully positioned to theoretically create an instant center, resting right near the heavy vehicle center of gravity. This is incredibly nearly optimal for most heavy drag racing applications. Highly educated mechanical engineers with advanced university degrees and incredibly sophisticated, expensive aerospace software have desperately tried to vastly improve on the basic, original ladder bar design for literally decades. And while they have successfully refined the metallurgical strength and adjusted the bushing materials, they have never fundamentally, structurally changed it. Today's modern ladder bars can consistently handle absolutely enormous, terrifying power levels. Heavy, steel-bodied cars consistently making well over 2,000 turbocharged horsepower routinely successfully use basic ladder bar suspensions to hook up. The entire patent situation surrounding these original ladder bars is particularly fascinating. That original, brilliant teenage inventor never actually patented his groundbreaking design. Whether by conscious, generous choice, or simply naive oversight, the fundamental, world-changing ladder bar concept instantly entered the open public domain immediately. This beautiful accident generously allowed dozens of aftermarket companies to rapidly produce their own highly competitive versions, massively driving commercial competition, accelerating mechanical innovation, and permanently keeping retail prices incredibly low for the average consumer. Had this brilliant design been heavily patented and licensed exclusively to one massive corporate entity, ladder bars might literally never have achieved their universal grassroots adoption. In the end, the legendary ladder bar story is fundamentally about significantly more than just basic rear suspension technology. It is about the incredibly stubborn, pure American spirit of grassroots innovation, the unwavering belief that there is always a significantly better, cheaper way, and the absolute proof that sometimes the single best mechanical solutions come from the most completely unexpected, humble places. He simply figured out exactly how to permanently solve it with very cheap materials and pure common sense. The next time you are standing at a local drag strip, take a quiet moment to look closely under the heavy cars sitting in the staging pits. When you see those simple, beautiful parallel steel bars, remember that sometimes the absolute best engineering solutions do not come from million-dollar corporate development programs, but from a kid with a cheap welder. What is your own garage innovation story? Have you ever solved a complex problem with a perfectly simple solution that utterly outperformed the incredibly expensive alternative? Drop a quick comment below and share your personal experience. Thanks for watching, and always remember, sometimes the best solution is just the simplest one that works.